Recognize Mr. Weber for 5 minutes.
Thank you. Are we going to be able to have a third round, do you think? Man, where do we start? Quantum computing. Well, let me back up because I'm on the heel of what Bill was saying. I'm really interested in that, especially when you start about gently doing something to the free market. So I'm going to go to you, Mr. Weiss. Are you getting, what's this, if you can tell us, what's the source of most of your aluminum?
Canada.
Canada?
Canada, yes.
Okay.
Yeah, because we deal so much in military products, we are actually restricted from buying aluminum from some sources.
Okay.
But nonetheless, we've always bought from Canada, and probably if we were doing commercial products, we'd buy from Canada.
Okay, well, that's good to hear. We're hoping to get the USMCA done, just FYI. So
yeah.
Thought I'd get that plug in there. I want to switch to quantum computing because, you know, last year was it last year, Henry, we passed out HR 6227, National Quantum Initiative Act about quantum computing. Are you using, or each of you using any of that? Maybe not you, Mr. Weiss, I don't know. But how are y'all finding that useful? And what percentage? And tell us how that works for you.
So the legislation, I believe, is useful from a national laboratory perspective. That is providing instructions and guidance to the national labs, to universities, that says the United States thinks that this is a very important direction to pursue. Through the Department of Energy, there have been a number of funding opportunity announcements, a recent one on quantum information sciences. Ames Laboratory won one of those awards on developing new algorithms and codes to work on quantum computers. There is the Energy Frontier Research Center program through Basic Energy Sciences within the Office of Science, Ames Laboratory, and many others recently won a new center award to develop topological semi-metals, which have the potential to contribute to quantum information science.
So you're not there yet, but you see it coming.
So there are quantum computers out there. Ames Laboratory does not have one. You can purchase a quantum computer, I think, through a company in the state of Washington. A number of labs do have those existing quantum computers where they are trying to further develop the capabilities.
Okay, and do any of y'all, and this could be for you too, Mr. Chairman, and you too, Bill, it seems like a week ago in the news that China cut off exports to Japan of a rare earth mineral or essential element. Did anybody pick that up in the news? No, that's not making sense.
No, you know, back in roughly 2010, China cut back the rare earths for magnet purposes to Japan. As some, I can't remember what they were fighting about, but
I was thinking like in the last week of news, I saw it come across my Apple Watch.
Well, I'm sure it's a threat there that's all the time in you know.
Well, my watch or the trade thing.
No,
yeah,
the Chinese threat. They know it's by the throat. Here.
Okay, well, I don't know if y'all were paying attention or saw that. So here's an interesting thought. In your discussion, Dr. Hayes, with Mr. Baer earlier, you talked about escaping using liquid helium and stuff like in some of the high heat areas. I'm thinking, how about waste heat recovery in those applications? Has any thought been given to that?
To the best of my knowledge, I do not know of that aspect being capitalized.
No? Anybody else?
I will point out that in the production of aluminum cerium alloys, which is my thing, that the formation of the intermetallic is exothermic, and therefore the total heat content per pound of aluminum melted is lower in the aluminum cerium alloy system.
So that's not necessarily. In some of Dr. Schwartz's testimony, he said that CMI researchers discovered a way to reduce the processing temperatures from 3,100 degrees centigrade to 800 degrees centigrade through electrolysis in a molten salt. Do you know what those correspond to in Fahrenheit, 3,100 centigrade?
Let me get back to you on that.
Okay. You're supposed to know these numbers right off the top of your head. no heat from this end, pun intended.
That's the National Energy Technologies laboratory work
Okay.
that I'm less familiar with.
So in those applications, there would be some possibility of getting waste heat recovery?
I suspect the answer is yes.
Okay.
Department of Energy, colleagues of mine have been discussing how to take advantage of waste heat for the last few years.
Right.
And I believe there are relatively small programs funded through DOE, but this is an area that is ripe for additional research. If you look at those Sankey diagrams that show where energy is going, a tremendous amount is going to waste heat, and there are opportunities to do something with that, whether it's create electricity or just put it back into the process for metalworking, for example.
Right. Well, I would suspect that the latter of those two would be the more friendly for for what you're doing, as opposed to try to put it to the grid. But anyway, these things just fascinate me. So I'm over my time, Mr. Chairman. I appreciate that. I yield back.